This is a bit of a recap of what we have learned so far. So say we have this function, and question A, sketch the function. Now, sketch is a bit sketch the function. Now sketch is important to remember. It's just a general idea of the graph, whereas graphing is a bit more means that you have to draw it quite precisely. Anyway, let's sketch the function. But before sketching the function, the domain is r minus 1/4, because we couldn't calculate the value of the function when x equals 1/4, as the denominator is equal to 0. So that means that there is an asymptote which is x equals 1/4. And also when x tends towards plus or minus infinity, well, the denominator is going to become very big, so that therefore 1 divided by something very big, that's going to be 0. So there is another asymptote which is y equals 0. That helps us to graph the function. So, okay. So x equals 1/4. Here 1/4, that's asymptote, x equals 1/4. And so, yep, it's going to look like that. And then on the other side, something like that. Okay. Now, question B. What is the equation of tangent to the graph at x equals 1? Okay, so the derivative. We need the tangent, we need two things. We need We need one, the slope, for which we'll need the derivative, and then we need the point. Well, the point, we already have it, in fact, because when x equals 1, f of x, f of 1 is equal to 1 over 4 times 1 minus 1, which is 5 minus 1, 1/4. So that means that it goes through the point 1, 1/4. So, okay, the derivative. Maybe I'll rewrite the function here. So f of x is 1 over 4x minus 1, which is 4x minus 1 power of minus 1. So therefore, the derivative is minus 1 over 4x minus 1 squared times the derivative of what's inside, which is 4. So at x equals 1, f prime of 1 is equal to minus 4 over 4 times 1 minus 1 square, which is minus 4 over 504. So that's 4 square, so which is minus 1/4. So therefore, using the gradient point formula, so if we know that basically the slope, the equation of a line which has for slope m and a point x0, y0 is y minus y0 is equal to m times x minus x0. So okay, let's apply that. So that means that the equation is y minus y0, which is 1/4, equal m minus 1/4 times x minus x0, which is 1. Yep. Okay, we can simplify that a little bit or reorganize that. So that means that y equal minus 1/4 of x plus 1/4 plus 1/4. So that means that y equal minus 1/4 of x plus 1/2 is the equation of the tangent at x equal 1. Right, second question, or third. Equation of the normal. At x equal minus 1. Right, so again, to find the equation of the normal, we need two things. We need first the slope, which we'll get from the derivative, and then we need the point. Well, let's find this issue. So at f of x, rewriting it again, 1 over 4x minus 1. So at x equal minus 1, f of minus 1 is equal to 1 over minus 4 minus 1, so it's minus 1/5. So that means that the point is minus 1 minus 1/5. And for the slope, f prime, well, we've calculated it before, it's minus 4 over 4x minus 1 square, minus 4 over 4x minus 1 square. Okay, so that means that f prime of minus 1 is equal to minus 4 over minus 5 square, which is 25. But hang on, this is the slope of tangent. But that's not what we want. We want the slope of the normal. But we know that the product of the slope of two perpendicular lines would be equal to minus 1. So therefore, m perpendicular, the slope of the normal, would be minus 1 over m, which therefore is minus 1 over minus 4 over 25, which is 25 over 4. Yes. And so now we use the gradient point formula to find the equation of the normal. So that's, again, I'm going to rewrite it. Y minus y0 is equal to m times x minus x0. So that means that y minus y0 is minus 1/5, minus 1 over 5. And m perpendicular in that case is 24 over 5 times x minus 1. Okay, we can simplify that a little bit. So that's y plus 1/5 equal 25 over 4x plus 25 over 4. So that means that y equal 25 over 4x plus 25 over 4 minus 1/5, which simplify as y equal 25 over 4x, and then 25 over 4 minus 1 over 5, 121 over 20, which is the equation we were after. Here we go.